In the previous notes, we looked at adding, subtracting, and multiplying polynomials, but we didn't touch division. So in these notes, we'll take a quick look at multiplying polynomials by a monomial, and then we'll look at what's called synthetic division, which can be used to divide a polynomial by a binomial. So first, to divide a polynomial by a monomial, just divide each term in the polynomial by that monomial. So first here we have two monomials being divided, 24x to the fifth, y to the third, divided by 8xy to the seventh. When you have two monomials being divided, you can also think of it vertically as just sort of an exponent simplifying problem like this. Either way is the same. We're going to do 24 divided by 8. That gives us 3. And then for the exponents, remember, just subtract them. So 5 minus 1 for x gives us x to the fourth. And 3 minus 7 gives us negative 4. And if you remember from simplifying exponents, a negative exponent needs to go to the bottom of the fraction. So this is going to be 3x to the fourth over y to the fourth. So there's your final answer there. Now, when you have a polynomial being divided by a monomial, like in example B here, we're just going to divide each term by that monomial. So first we'll do 8x squared y to the third divided by 2x y to the fourth. So 8 divided by 2 is 4. 2 minus 1 is 1. 3 minus 4 is negative 1. And we'll go ahead and deal with the negative exponents after we divide completely, just to keep it orderly here. Now we'll do the next one. 10 divided by 2 is 5. Keep that negative sign there. 7 minus 1 is 6 for the x's. And 1 minus 4 is negative 3. So we just have to change these both to fractions. We've got 4x over y minus 5x to the sixth over y to the third. And there is our final answer. Looks a little messy, but that's just what we should do. It's better to have these fractions than to have our negative exponents. Now let's talk about synthetic division. It is a really quick way to divide a polynomial by a binomial in the form x minus r using the coefficients of each term. So we write out the coefficients of the dividend, that's the polynomial being divided. So here you can see we've got 2x cubed, so a 2 here. We got negative 13x squared, so negative 13, and so on, 26, negative 24. Okay, and then we write the constant r from the divisor x minus r in a little box right here. Notice that it's x minus 4 when we have a positive 4. So if it was x plus a number, we'd have a negative number in the box here. And then the steps to do this, we're going to bring down that first coefficient right here. You see the 2 got brought down. Then we multiply that by the number in the box, the r number, 4. And then write that product under the second coefficient right here with that 8. And then we add negative 13 plus 8 is negative 5. And then we just repeat that. Negative 5 times 4 is negative 20. That goes here. And then we add. 6 times 4 is 24. That goes here. And then we add and get 0. And then our answer, these are the coefficients of the answer polynomial. So we just write that out, starting with the constant, which is this last, second to last number here will be the constant. So it's 1, the degree of the first term is 1 less than the degree of the dividend. So here we start with 2x squared minus 5x plus 6. And now if the final number here is not 0, here it was 0, this is the remainder. So if you remember, like long division with numbers, you get a remainder occasionally if it doesn't divide evenly. So if you don't get a 0, it is a remainder, and I think we'll see how one of those will work in these notes. One other important thing to talk about is that missing terms in the dividend, that's the polynomial being divided, must be represented with a 0. And again, I believe we'll see at least one of those in these notes, so you'll see what that looks like as we go through. So let's practice this. We're going to divide x squared plus 3x minus 40 divided by x minus 5. So here's how this gets set up. Write this number, 5. Make a little box around it. That's our R value. and then we're going to write the coefficients of our polynomial that's being divided right next to it. So we've got 1x squared, 3x, and negative 40. And we'll draw a line here. Under the last number, the negative 40, put a vertical line, because this is our remainder, if there is one. So now we can do this division. So first we'll bring down the first term and then multiply. 1 times 5 is 5. 3 plus 5 is 8. 8 times 5 is 40. Add this together, we get 0. So there is no remainder in this problem, which is great. Now we can write our answer out. It's just 1x plus 8. Because those are our coefficients of the answer. 1x plus 8. That's all there is to it. Let's try another one. So we write our number 3 here in the box. Write the coefficients of our dividend, 1, 7, and negative 30, like this. Okay, bring down the first number is a 1. 1 times 3 is 3. Add down, we get 10, and 10 times 3 is 30. And again, we get 0 for a remainder. So our answer here is x plus 10. And you can put the parentheses around it or not. I didn't on this first one. It doesn't really matter. Now, what I want you to notice, especially about these first two, these were both quadratic polynomials. And so if you think back to factoring, these are the two binomial factors that we would get if we factored the polynomial. X minus 5 times x plus 8 does equal x squared plus 3x minus 40. And same thing for example B. So these two examples are great just kind of for showing this process. This is another way that you can divide and get your binomial factors this way. For C, again, we're going to write that number in the box. Now here we have a positive, which remember, the rest were all negatives. So we need to write a negative 1 in the box because this is x minus negative 1. And then our binomial coefficients, 1x cubed. And notice there's no x squared, so we have to put a 0. And then a 1x and a 2. Okay, now we can divide. Bring down the 1. 1 times negative 1 is negative 1. Add down, we get negative 1. Times negative 1 is positive 1. Add down, we get 2. And 2 times negative 1 is negative 2. And again, we have a remainder of 0. So to write out our answer, we start with it 1 degree less than the starting polynomial. So this is going to be 1x squared minus 1x plus 2. And you can write the 1s or not. I chose not to. But if you wrote 1x squared minus 1x plus 2, that would be also okay. That'd be fine. Last one here. We have minus 3 again, just like the one above it. So we'll put 3 in the box. And then our coefficients are 2, negative 13, 26, and negative 24. No zeros this time. So let's bring down that first one. 2 times 3 is 6. Add down, we get negative 7. Negative 7 times 3 is negative 21. Add down, we get 5. And 5 times 3 is 15. Add down, we get negative 9. So we do have a remainder here. And I'll show you how that works. But before I do, it might be helpful to remember what remainders look like in normal division. So let's say I have a problem like 21 divided by 4, right? 4 goes into 21 5 times. 5 times 4 is 20. We have a remainder of 1. And that remainder gets put over the divisor. So this is 5 1/4. We're going to do the same thing with this remainder and put it over the divisor as a fraction. So here's what that looks like. So our answer, we have 2x squared, right, minus 7x plus 5 minus 9 over the divisor, which was x minus 3. So there is our answer. That is what we get when you divide 2x cubed minus 13x squared plus 26x minus 24 by x minus 3. We get 2x squared minus 7x plus 5 with a remainder of negative 9 over x minus 3. So whenever you have a remainder here, you're going to put it as a fraction over the divisor. Looks a little messy, but that is how it works. So that is synthetic division. Pretty quick process for dividing. As long as you don't have a remainder, it looks pretty clean.